about that in Purim. There's two big mitzvahs that we have in Purim, which is Matanas Yoyim, and we have Shalach Manos, which is all about others, right? It's all about other people. And he said, what's the essence of that? He said, can you imagine on the day after, and Yud Gimel, right, was Gezerah, and then Gezerah was Batal, and Yud Dal, when people came together to shul and they saw each other, like everybody, it was supposed to be every single person, Nashim, everyone was supposed to be eradicated, completely killed out. And right, the whole Gezerah obviously did not, it was broken. And then when the next morning, when everybody saw each other, there was that simcha of seeing another person, like I'm alive, you're alive, we're all alive, we're all together. There was that simcha of seeing another Jew. And he, he was trying to kind of be machazet. Everybody, we all matter. Everybody matters to one another. And I think specifically in this group, there's a certain energy every time people come to the meetup. Everyone's very happy to see each other. Everyone's really, we definitely have a certain common interest that we all have, and we genuinely are excited to see each other. And I want, just kind of let's take that energy, let's take that excitement, and let's try to help one of our own. Fabi was a great individual. I unfortunately didn't have the privilege of knowing him for that well, but he was a sweet guy. We all really at Madison, we all got close to him in a very short period of time. He's a great guy. So let's use this thing that we built, and let's use it for a positive, and let's try to extend ourselves. Again, I'm not a fundraiser, but whatever you can do to help families would be tremendously, appreciated. But before the speaker himself is going to speak, Itcher Rosenbaum, the owner of Madison Title, would like to say a few words. So, if you don't mind.
Just a few short words to welcome everyone. I think it's a tremendous Kiddush Hashem that people from a like-kind profession come together and feel an achrayus for one of the B'nai Chabura who share the same profession. Is really, Echad B'nai Chabura Shemeis Yida Kol Chabura Kula, and for people that all have the same profession to feel that they want to come out, the feeling of achrayus, and they feel that they feel one for another, is a tremendous Kvod Shemayim and a tremendous Kiddush Hashem. We learned recently in the Gemara discusses that there was a theater in Alexandria where the Gemara discusses that there was, at certain times, there was twice as many people as Yotzei Mitzrayim. There was up to 1.2 million of people that were in this theater at the same time. The Gemara discusses how there was different sections, how the goldsmiths sat in one area, the silversmiths sat in one area, and different people from different professions sat in their own area. We also find the Gemara says that there were different shuls that were segregated by profession. I once heard of Pshat that the reason why the shuls were segregated by profession was because usually when people are in the same profession, so they're competitive with each other. And Chazal wanted that Dafka put people who are competitive with each other for two reasons. Number one, to create achdus together, and number two, knowing that they won't talk to each other, so there won't be any talking by Dafka. So they would Dafka put people from those professions in these shuls. Of course, that's not the Pasuk Pshat, but they put people in these shuls together so that they should Dafka be able to be together and to be mechazik each other. Another reason why they put them together to daven in the same shul was when someone sees that someone from my profession is able to come early to davening, then what that shows is, wow, I don't have a teretz to say that I can't come early because I'm in this profession, I'm in that profession. Everyone from within their chabur of the profession that they come from is a mechayiv on everyone else from that chabur. And I think that Lakewood Devs coming together and feeling an achrayus of Echad B'nai Chabura is something very, very special, that we come together and we feel. Fivey was only here for a short few months, but the Eibishter was made that this should be the last place where he was, and we all feel a tremendous surprise. And seeing how like-minded people not only come together to share best practices in the industry, but also feel that they want to be able to share best practices in being B'nai Torah and caring for each other. What a Kvod Shemayim and what a Kiddush Hashem, and it should be a source for all of you. We should be zeichet that when we be able to come together for meetups, Mitzvah Hashem, for Gitta Zachen, and only for it should be Mitzvah Hashem a tremendous Yata D'Shmai, and it's source for us all.
My father called me up a few days ago and asked me if I could speak for this event, this parlor meetup. It reminded me of a time about a year and a half ago. My father called me up and asked me if I would be interested in giving a shir on Kiddush Hachodesh to the From Kehillah in the Philippines over Zoom. And at that point, I knew a lot about astronomy. I knew not so much about the Ram Kiddush Hachodesh, and as far as I was concerned, my Excel was like Microsoft Word, just in like in graph paper, graph fashion. And I knew there was some way to do like 1 + 1 = 2 in there, but not much more than that. And my wife still remembers the fascination I had the first time she showed me how to use a if function and or functions. And using those, I was actually able to accomplish a lot of things which made the process a lot easier, and eventually ended up going on to the next month, opening up a chabura in Beis Hashkaveh, which went through the Sukkot of Kiddush Hachodesh from beginning to end. Now, you may notice here the system that we have running over here is a Earth-centered system, a Sun-centered system. I'm sorry. The system the Rambam used was a system which was in use for thousands of years before that, was not a sun-based system, an Earth-centered system in which the Earth was the center of everything. And the biggest problem everyone has is, what do you mean gravity and everything? How did it work out? There was no gravity. Things just fell down. So if things just fell down, why didn't the Earth and the Moon and the stars also fall down? So in order to answer this question, there were a lot of different people who had different pirushim on what was going on. Was generally accepted the mahalach of a eudoxus of Knidas, who developed a system where there was basically solid spheres which the planets were embedded in, and this was later shown to be didn't work with the reality, so it was later dropped for a epicycle system, which I'm going to explain in a minute, which was later perfected from Apollonius of per something, and later perfected by Ptolemy, who was also brought down in halachic references as Talmai, and mistakenly in some places as Talmai HaMelech. They are not the same person. Now, as I advanced in knowledge of both history of astronomy in certain cases, and as I developed better knowledge in trigonometry, my functions, which used to look something like that, were reduced to something more like that. And as I got more advanced, I came across some new functions which are unfortunately available only in the beta insiders for Excel. So if anyone has it, I can send these out, but I didn't bother sending them out. Most people wouldn't be able to open them with their computers. And that allowed me to reduce these functions down to this.
All the good stuff's always in beta.
Yeah, exactly. I'm sorry, yeah, but the lambda functions aren't available yet. Now, the epicycle system is more like a system which we have the Earth in the middle. We have a sphere, we'll call it this green sphere, which the planet moves around at a steady rate, and then we have a purple sphere in which the planet rotates around as it moves around. So we basically have this sphere moving around the sphere, and as you can see, it therefore causes the planet, which in this case is Mars, to slow down, take a reverse, and start going forward again. Now, the same thing would happen with the moon, which is, if you have the papers they have, the scale of the moon's epicycle is shown over here, where that little tiny gray dot over there up there is the moon. This is the Earth. Epicycle would be about that size. So we have the epicycle moving around, and this epicycle moving around the Earth once every month. So this would cause the moon to sometimes go a little bit faster, as when the moon is on this side moving that way, and the epicycle is moving that, and the epicycle itself is moving that way, then it appears to be moving faster. When the moon is on that side moving backwards, and the entire epicycle is moving that way, it appears to be moving a little slower. So the moiled that we have, which our calendar is based on, uses the average moiled, which is the center of that epicycle, which is also known as the deferent, or the Emsayer in the Lashon of the Rambam, where that deferent is, and that is what the calendar is based on. However, when Bezdin has to know whether the Eidim are saying the truth or not, we have to know not just whether what the approximations are, but whether they could have seen the moon in actuality or not, and to know exactly where the moon is. So in order to calculate that, this is only part of the cheshbon, but the first step we're going to have to know is, we know that the moon moves around the epicycle at a constant rate, and we know that the epicycle moves around the Earth at a constant rate. And based on knowing where those two are, we have to know where exactly the moon is found at this time, which is the second diagram is more focused on this more. The moon can be up to 5 degrees in either direction, up to either at 50 degrees or 40 degrees in this case, where the NCRF or is at 45. The moon can be up to 5 degrees in either direction. And what we have to do is figure out, by using some mathematics, where exactly the moon would be found, assuming, let's say, as you have over here, that you have the moon being, in this case, is 45 degrees along the epicycle, and 45 degrees along the epicycle from the point of opposition, and the moon and the center of the deferent is the center of the epicycle, which is the deferent. What this orange dot over here is 45 degrees away from the starting point, which is here. Now, I'm going to have to, unfortunately, take you back to high school for a moment, to trigonometry. For those of you who don't know trigonometry, you don't have to understand it to know what's going on, but it will make it a little more interesting if you do. So just a few basics to remind everyone. There are three main ratios in a triangle. There's a sine, cosine, and tangent. And those are as follows. Every triangle will have three sides and three corners. Now let's look at this, focus on this side for a minute. Let's call this corner A, or angle alpha. Angle alpha is, let's say, this is not 45 degrees, but let's assume that angle alpha is going to be 45 degrees. Every triangle has a 45-degree angle, regardless of how large a triangle is. The difference between side C and side A is going to be the same regardless of how big the triangle is. The difference between side C and side B is also going to be the same, and the difference between side B and side A is also going to be the same. Now there is a ratio that has a kind of curve, wave curve, which is, you may have come across sine curves even if you don't know about trigonometry. And that's because when a triangle would be 0, it would have the opposite side would be 0 relative to the hypotenuse. And if the triangle was 90 degrees, which means if side C was straight up, then it would have a side which would be this exact same as the triangle as side C. So we find these by taking side A divided by side C is equivalent to this, is the sine of this angle. Cosine would be side B divided by side C, and side A divided by side B would be the tangent. And any calculator or whatever have all these functions. You put in, let's say, sine of 20, and it will give you whatever the difference between side C and side A is in a triangle whose angle is 20 degrees. And the same goes for tangent. There's also a function called the arctangent or arcsine, which is also sine minus 1 in some calculators, which is the opposite. Basically, you put in what the ratio is, and it tells you what the angle is. So for all those who got that good, for all those who don't worry, you don't have to really know for the rest of this. So getting back to our triangle here, we have a triangle here. We know how far away the center of the epicycle is from Earth. We know how far away the moon is from the center of the epicycle. We know the diameter of the epicycle. Now we have to know is we have to calculate what this side is, what side B1 is, and what side A is. Once we know that, we can figure out the difference between where the moon appears to be and where the center of the epicycle is, which would be angle delta. So if you remember from what we just said a minute ago, angle delta would be side A divided by side B, would be the tangent of that would be angle delta. So being that we don't know side B or side A, but we do know side C, well, we can use the sine and cosine of angle alpha, which is how far away the moon is along the epicycle, to figure out what side B1 and A are. Now I'm not going to go through the exact calculations, but we basically take the sine of alpha is going to be A, the sine of the cosine of alpha is going to be B1, and we take B1 plus B2 is side B, and then we divide A by side B, and that equals the tangent of side the tangent of the angle delta. So you can see the function over here is we have the tangent of sine d, which is a function I made for unfortunately Excel works with radians and not angles and not degrees. So I had to make a function to work with degrees, which I'm sure everyone is familiar with. A circle has 360 degrees. And what you might not have noticed is that there's a method of calculating. It doesn't use a decimal system, but uses the sexagesimal system. There's an article in Course of Java about it, which uses a 60-base system. Our clocks are based on that, which every degree is split into 60 minutes, every minutes of arc, or arc minutes. Every arc minute is split into 60 arc seconds. Every arc second is split into 60 arc thirds, and so on, arc fourths, and so on and so forth. So all the numbers are given here in degrees, minutes, and seconds, and that is how the Rambam used the system. Actually, I had to make a custom function, which had a lot of ups and downs until I got it to work perfectly, to make the sexagesimal function, which is this function. Now, like I said, it won't work in won't work on most computers, but you could convert this into a let function, which will work on most computers by turning the lambda into a let and putting your references, or in this case, it would be whichever number you want to turn into a sexagesimal number, and the amount of sexagesimal places you want to round it to, and then you have to remove the format because it doesn't know how to deal with with optional parameters. The function then basically divides takes your number, divides by 60, and takes the integer portion, turns it into, let's say, degrees, takes the decimal portion of that number, multiplies it by 60, takes the integer of that, turns it into minutes, and takes the remainder, multiplies that by 60 again. And there are a lot of bugs that can come up. For example, if you're dealing with multiplying 0.999, then if you want to round it to, let's say, one sexagesimal place, you're going to have an issue because it's going to give you 59 minutes, let's say 59 arc minutes and 60 arc seconds, because it will round 59.9 up and it won't know to turn that into 1. So, and then rounding that before led to other problems, and Baruch Hashem eventually was able to make a formula that worked. If other months after and there's enough time, I could maybe explain exactly how I did it. Point being that the Rambam gives numbers for how much to add or subtract. You have it in on the second page. We have this graph the Rambam gives, which is also the Lashon the Rambam in the beginning of page 1. And you can see where the Rambam gives the money for if it's at either to add or subtract, depending on whether it's less than 180 or more than 180. For 10 degrees, 50 minutes. For 20 degrees, 1 degree and 38 minutes. For 30 degrees, 2 degrees and 24 minutes. And so on. Now, when we run the calculations, as we're going to go through in a minute, you'll see that the actual numbers are not all in agreement with what the Rambam says. There are some of them that are apparently rounded in the wrong direction. So, for example, let's say 137.31 would round up to 138, meaning 31 is closer to 60 than it is to 0. But 0.4920 should really round up to 50, or should really round down to 0 degrees and 49 minutes, as opposed to being rounded up to 0 degrees and 50 minutes. Now, when it comes to that, and as well when it comes to 100, we can say that the Rambam rounded them because 50 is a nice round number, and it's easier to work with. And when it comes to 100, it would be, for all those of you who didn't understand the calculations, and for anyone else going through the Rambam who doesn't know trigonometry, it seems kind of counterintuitive to say that 100 degrees, which is further down of the circle, already closer to the center of the circle, would be larger or be a greater distance than 90 degrees. So again, it's not off by so much. So those two we can get away with, and most academics and almost everyone else, and actually everyone else I saw, takes the rest of the numbers and just kind of stuffs them under the carpet and says like the Rambam was wrong, or it's a mistake, or he didn't know what he was doing, or he just copied the tables from somewhere else and he got the numbers wrong, or other things like that. Now, I don't like those type of people, and I don't like those type of things. We're dealing with Rambam movie, we're not dealing with with your next door neighbor. So, but my side didn't have any help until I tried running some calculations, and then all of a sudden the answer was very clear. And in order to understand, now we're going to have to see what do we do when we have, let's say the monad is 15. What do we do if the muscle is 15? So the Ram tells us if it's 10 or it's 20. If it's 15, what do we do? What do we do if the monad is, let's say, 65? So on the first page, you have the Rambam brings down over here, and the Rambam references it in the next halacha which I have here. References Parak Gimel halacha Zayin, in which the Rambam says that you're talking about here over here about the sun, that you take the difference between the 10 above and the 10 below, which in this case, 10 for the monad for 60 degrees is 1 degree and 41 minutes. The monad for 70 degrees is 1 degree and 51 minutes. The difference, therefore, is 10 arc minutes. So we take each increment of degrees, so 61, 62, 63, 64, each one of them would be 1 arc minute more, being that the difference between 60 and 70 is 10 arc minutes. So in the case of 65, we take 70 minus 60, which is going to be 10, divide it by 10, and multiply that by the amount of degrees. So, for example, 65 would be 1 degree and 46 minutes, which is 5 minutes more than 1 degree and then 60 degrees. And for 67 degrees, then it would be 1 degree and 48 minutes. And we do this for any one we want. Now, it's very easy to do on pen and paper, and very painful to build a function for. And this is probably not the most efficient way to do it, but this is the way. So I made this function that takes an input of what type of mono we're dealing. There are 2 types of monos. Some go up to 180, some only go up to 90. And it takes an input of how many degrees we're dealing with, in this case 1. And then takes an input of all the different monos. If it's what it was, 10, 20, 30, 40, 50, 60, 70, all the way up to 170. And then takes those monos, takes those numbers, and divides the number we're dealing with by, takes the number that divides it by 10, and then if it's 1, we take the amount of 10. If it's 20, we take the amount of 20. I'm sorry, and that's lower amount. Then we take the same thing, round it up, and grab the amount above it, and then divide the difference between the 2 by 10, and add that to the lower amount. Now, after we run that and compare that to what would have happened if we would have used the, so to say, correct mono, you can see over here the ones that are highlighted are the ones that don't match up to the trigonometric equation that we used it for, and you'll see that by using the wrong mono for 30 degrees, they're actually overall, between 21 and 39, they're actually more accurate than using the correct mono for 30, which would give you 6 numbers that are off as opposed to 5 by using the wrong mono, by using the so to say incorrectly rounded amount. Now this sticks out even more when we get to 80 degrees, in which you can see over here that if the Rambam would use the correct number for 80 degrees, if the Rambam would have rounded that 1 degree, the 4 degrees and 58 minutes and 11 seconds, if the Rambam would have rounded that down the way he should have, the only one that would have been correct would be the one of 80 degrees. Yet the one of every single other number between 70 and 90, they all would have been wrong, as opposed to rounding it incorrectly actually leads you to be far more accurate overall. And the Rambam wasn't trying to build you a table that was telling you 10 accurately and 20 accurately. He was trying to build you a table that would tell you for all the months, which it could be 25 just as often as it would be 20, what the correct number, which number is going to get you the correct amount, the most amount of times. We find this also by the next measurement the Rambam gives for the lunar latitude. As some of you may know or not know, we don't have lunar eclipses and solar eclipses every single month. And the reason for that is that the moon's orbit is inclined a little bit to the sun's orbit. So we have, let's say, the sun orbiting like this, and the moon's orbit would be something like that. And therefore, sometimes it's north of the sun's orbit, and sometimes south of the sun's orbit. So in this case, the moon here is a little bit south of the sun's orbit. It would be south along this entire side, then come north, and go around and be north that side. Now we have to know how much the moon's latitude is in order to know whether you can see it or not. And when they're put through this function, which I'm not going to go through, it's spherical trigonometry, which you will not learn in high school or in college unless you're learning advanced astronomy. And that gives us a table of these numbers. And again, you see that the number for all of them are correct, with the exception of one of the mono for 20 degrees, which rounding means is 143, and really being that it's 142.29 should be rounded down to 142, and again, why round up to 143? Now, if we go back to our chart over here, we can see again very clearly that using the correct mono would give you all of those wrong, as opposed to using an incorrect mono, which would give you only one wrong, and overall it would be far more accurate to use the incorrectly rounded mono than to use the correctly rounded mono. Thank you very much for listening. I'd really love to be here when I take questions. There's a lot more to say on the subject. There's, as far as making calendars, actually far more that can be done using Excel and I'm assuming other programming languages, which may be better geared for this type of thing than Excel is. But had I not used this and had I not done this to Excel, I never would have realized the answer to this question, which was apparently bothering everyone. Everyone talks about it, but nobody gives an answer to it. And yeah, I mean, with the power of programming, there are a lot of times where you can realize things which would otherwise not be able to realize without that tool.